Alright, so a couple years ago, VEX unveiled this wonderful system that we have today for our robotics competition. That being this wonderful brain system that has all these really cool features and things, but along with all of these wonderful features that they've given us, there's also a relatively major problem with their $380 brains, and that is the fact that these ports, these smart ports that they've given us, are quite easily damaged by static electricity. And today I am going to be showing you how to fix those ports. But first, a disclaimer. This is probably not within the rules of the competition of VEX. I do have to say that beforehand. We are not necessarily fixing the issue here. We are only restoring the functionality of the ports, so we are not changing the function of this thing at all. We are simply repairing it, but opening up a VEX component and playing around with the insides, I do not believe is allowed by the rules of the competition. But in the case of our team, we are just repairing these to use on test bots. We've already purchased new ones to use on our actual competition bots. And we've done that because we didn't realize we could repair these at the time, but we can, and today I'm going to be showing you how to do that. I'll go ahead and put some timestamps on the video now, and I'll put those in the description as well, because this video is probably going to get kind of long. Also, kind of continuing the disclaimer a little bit, this is going to require some soldering, and it's not the easiest repair ever to make. So first off, the culprit, the thing that actually goes bad, these guys, I will put a link in the description. The part name is like super long, but it's right there. It is a RS-45 transceiver. So these smart ports just use serial to communicate with the motors and whatnot. And the serial communications needs transceivers, and that's what these things are. And these are actually incredibly expensive chips. These are like $4 a piece, which seems like an absolute ripoff. And I think the reason why they chose these specific chips for the brain is the fact that they are rated to be, the data lines are rated to be shorted to the battery voltage that this thing comes out, because these are actually chips that are made for automotive use. And if you're curious, these are the chips that we're going to be replacing. There's a little 8-pin surface mount package. Besides that, you're going to need some tools. You are going to need a soldering iron. So you're going to want a hot air station for soldering as well. I'll show you later why, but the chips are kind of a little bit difficult to remove, especially if you're just trying to do it with a soldering iron. And I've repaired one of these in the past only using a soldering iron, and I think I ended up doing more damage to the circuit board really than good. But doing this with the hot air gun seems to work really well. You are going to want some flux. Obviously you're going to need a bit of solder. And you're going to need a Phillips screwdriver to pop this guy apart. And you're also going to want a thing of solder wick to clean up the solder off the circuit board. Step one of this process is to determine which ports are broken. So we're going to bring in a battery. We'll go ahead and plug that in. And we're also going to need some device that connects to the smart ports. Doesn't really matter what it is. I usually just use a motor. So we'll take our motor and the cable, and we're going to go into the devices menu. We'll start on port 1, and when we plug that in, you'll see that this shows up, or the motor shows up here on port 1. And if you look at the motor itself, you'll see that this light here is solid orange. And we can go into the motor, of course, and it'll show the whole menu and stuff, and we can, like, you know, spin the motor up just like normal. That tells us that port number 1 is good. We can go ahead and move on to port number 2. And you'll see that port number 2, the motor is recognized, and we have the solid orange light on the back of the motor again. Move on to port 3. And you'll notice nothing showed up this time. And if we look at the motor, you'll see that the light on the back of the motor is no longer solid orange. It is blinking just for a split second there every once in a while. That is a sign of a bad port. So I'm going to go ahead and note that port number 3 is bad. And of course, there's like, we can hit port number 3, it doesn't do anything because it's not even recognizing that anything's plugged into it. And we can keep going with this. Number 4, solid orange light, so that one's good. And sometimes it does weird things like this, where if you move it one port over, you'll see that that motor's actually showing up on port 3 and port 4 now. So it does some kind of weird things sometimes, but yeah, anyway, we'll keep moving down. Port number 5 is good. Port number 6 is not good. Anyway, you guys get the point. Just go through here. Anytime you see that light just kind of flicker like that, that means that you have a bad port. We have seen some ports that do other weird things, like if the light doesn't come on at all, the fix that I'm going to show you in this video isn't going to help you. But if you've got the blinking port like that, that is what we're going to show you how to solve. So there are some ways to fix, or prevent, I should say, damage to these ports. One of those things being the anti-static field tiles that VEX came out with this year. And before that, or if you don't want to purchase the anti-static field tiles, you can use a product called Staticide, which you can just spray over your existing field tiles, and it actually seems to do a pretty good job of reducing the static buildup on the tiles. I will also note that the chips that I showed you guys earlier are actually in both the motor and inside the Cortex. So sometimes the motors can exhibit this issue no matter what port you put them on. And that issue can be solved by switching the chip inside the motor as well. I'm not going to be showing you how to do that today, but that is just something to keep in mind, is that the chips inside the motors and the sensors can go bad as well. But usually it is the ports inside the Cortex that go bad. I have 11 dead ports out of a total of 21 ports, so this one is fairly well cooked. We've had one that was worse. We had one that was all the way down to 6 ports, and I repaired that one to some degree, but that was also kind of the test victim of our of our experimentation here. All right, so next step, unplug the battery, and we'll go ahead and flip this over. It'd probably be a good idea to put the screen protector over it, but unfortunately I am not currently in possession of the screen protector for this guy. But we're just going to go ahead and grab a number 2 Phillips screwdriver and whip this thing open. Not really too much to this, it's just 4 screws and our back cover is going to come off. So back cover comes off, and this should just pop off of here, just like so. One thing that I will note is that there is a forum post by one of the members of our club, actually, that I'll link down in the description as well, that kind of went through and gave you the process of how to do this stuff in text. I am going to vary from his instructions a little bit, because when that was posted, there was some information that we hadn't really known yet. One of the things I'm going to deviate on is he says not to take this board out any further than this. I am going to take this board out all the way, because if you notice, there's the 4 plastic things that I just pulled the screws out of. And if you don't pull this board out, you're going to end up melting these guys with the hot air later. So we're just going to go ahead and completely remove this board. It's not too difficult to get out of here. It's just a connector on the bottom that you have to be a little bit careful with. But again, it's just 4 more screws. It should pull straight out. And you'll see all along the edge of this board, all of these guys, these are the chips that go bad. So with those 4 screws out, we should just be able to lift this board straight up. And it should just pull off of here. It's a little bit tricky to get out, especially when there's a camera in the way. And then, if I remember right, there is a ribbon cable that you have to disconnect, which is right there. And I'm not going to be able to get a good shot of that, but I'll show you how it works when I pull it out. So the thing I just disconnected was this ribbon cable, and that comes out of this connector right there on the board. And the way it works is when it's in there, this thing's going to be pushed flat. You just get up in there with your fingernail and pull that up, and then that connector will pull right out of there. So relatively easy. It's just a little bit awkward because of the way that it's put together. Alright, so we are going to need this piece for one more step, or if you have another brain, you can use that as well. One thing that I am going to tell you to be careful about is these little white things here. They kind of look like springs. They're a little weird, but what those are for is holding in the little magnets, and the magnets, of course, hold the screen protector on. But these are kind of a pain to get back in if you knock them out on accident, so I definitely recommend holding them in or not flipping this thing upside down. If you can avoid flipping it upside down, that'd be great, but I'm going to flip it upside down once just for demonstration purposes so you can see how the ports are numbered on this. So you can see the ports there. Now when you flip this upside down, port number 1 is here, And then this guy over here would be port number 10, and then port number 11, I believe, goes back to this side, and then this is port number 20, and then port number 21 is the one that's kind of chilling over here in the corner. So what we want to do is just mark the chips that we want to remove. The best thing to use for this would probably be like a silver Sharpie, but I've got a red one, and that's what we're going to use. So chip number 3, that's this guy. That's bad. We're going to get rid of that one. Chip number 6, which is 1, 2, 3, 4, 5, 6. That's this one. Going to get rid of that one. Chip number 7, which is the one right by 6. Get rid of that one. One tool that I forgot to mention is tweezers. You're going to use these to grab onto the chips and pull them off. Our next step is to go ahead and come in here. We'll turn our hot air station on. We're going to set it to a temperature of 375 degrees Celsius, and we're going to set our airflow up fairly high. I'm setting it to 6 out of 8 for now. We're going to see how that works. And for the tip selection or the nozzle selection on our hot air gun, I'm using the largest nozzle that this thing came with, which is probably about as big as around, which is probably about as big around as a pencil. But what we're going to want to do is come in here and just heat up the area around this chip. Now we do want to be kind of conservative with our airflow. The reason why I'm not just cranking the airflow to the max is so I don't accidentally just blow one of these chips completely off the board. So our goal here is pretty much just to slowly heat up the chip. The first one is going to take a very long time. And one thing that you'll notice is that 7 out of 8 of the pins on this chip are going to melt relatively quickly. And then the last pin takes absolutely forever to get off. That last pin is the pin that is soldered to the ground plane of the circuit board. And the reason why that one takes so long is because that ground plane inside the circuit board is acting like a heat sink, and it's pulling all the heat away from that pin, and it's preventing your solder from melting. So it takes quite a while to heat that one pin up. But once you start getting your board warmed up, it gets a little bit easier to get the rest of them off. If you come in here and you just kind of poke at it with a pair of tweezers, it'll just slide right off the pads. And I should probably be poking at this from the other side because I don't want to wipe that little capacitor off the board, because it is quite likely that everything on here, or that all the solder on here, is going to end up melting. And it's going to make it quite easy to remove components that you don't want to remove, such as all the little resistors and capacitors that are around the chip. This whole board's going to get pretty hot pretty quick as well, so you're going to want to be careful when you're touching it to move it around and things like that. The reason why I mentioned one of those pins is going to take a long time to completely melt is that you're going to notice that eventually you're going to be able to just poke at this chip with your pair of tweezers, and it's going to slide except for one of the pins. So one of the pins will be stuck down, and you will have a very strong temptation to just go ahead and grab that thing and pull it off of the board. That is a very bad idea, because what you're going to end up doing is just ripping the pad off of the circuit board where that chip is. So you do want to heat this thing up to the point where you can just barely tap it with a pair of tweezers. It should just slide right off. It does take a very long time to get this board warmed up. In fact, I'm probably going to go ahead and bump up my airflow a little bit on the hot air station just to try to speed this process along a little bit. And there we go. You see that just slid right off. I can go ahead and just pull that up now. And we'll set that off to the side for now. So my next ones are 6 and 7, so that's those two. And having the airflow up this high doesn't seem to be hurting anything, so we'll just go ahead and leave it. But we can take that chip and just move it off to the side. The idea is you don't really want to leave this air gun pointed in one spot either. You want to keep kind of moving it around in a circle around the chip until the chips come free on their own. And you'll notice I'm trying to slide them that direction, and that is just because sliding them that direction won't hit any of the other components that could possibly be in the way. So sliding them up like that won't cause them to wipe out any other components that will probably also be unsoldered in the process of heating up the board. And I can see that that one's close because when I touch it, some of the pins move just a little bit, but as I said, you don't want to get tempted to just rip the thing off. You want to just be patient with it. Give it some time, let all the solder melt, and it will eventually just slide right out. Alright, so these are the chips that I have removed. All 11 of them here. The whole process took a little under 20 minutes, so it's not the fastest thing ever. But yeah, you just gotta take your time, be careful not to damage the circuit board, and you'll be just fine. Right now this board is incredibly hot and you can just feel the heat coming off of it. But anyway, these chips can now be thrown away. So next step is to clean our board up a little bit. So we're gonna take some solder wicks, some flux, and a soldering iron. We're just gonna clean the old solder off of these pads, just so that when I put the new chip down, it's gonna make it sit there nice and flat and I can solder it a little bit easier. So right now I've got the soldering iron set up at 700 degrees. Of course, all this is lead-free solder, so we're kind of soldering a little bit hot. But what I'm gonna do is take a little bit of this flux and we're just going to spread it out around where the pins are. We're not gonna put very much on here at all, but the flux helps tremendously when it comes to allowing the solder wick to do its job of pulling solder into it. So I'll go ahead and clean off my iron tip, and we'll come in here and just kind of dab this stuff along the pads, and it should do a pretty good job of just pulling up all the solder that's on that board. And that's just going to make it nice and easy for us to solder on the new chip. So we're just going to keep going with that. And our last step here is to go ahead and just clean some of the flux residue off of these pads. That'll make it a little bit easier to solder the new chips on. The flux that I have seems to come off pretty easily if you just give it a little bit of wipe with a towel. Some fluxes you may find that it's a lot easier to add some alcohol or some acetone or something like that in order to clean the flux off the board. It doesn't have to be perfectly clean or anything, we just want to get enough of that residue off to where we can get to the pad and get some fresh solder on it without having to go through the old flux residue. Alright, so I am going to change my soldering iron tip out for a nice fine chisel tip. This is a 1.2 millimeter chisel, and that's what I'm going to use to solder the chips back on with. Another potential thing you could do, instead of hand soldering the chips back on, you could take some solder paste, put that on the pads of the board, and then just stick another chip into that solder paste and heat it up with the hot air gun. Unfortunately, I don't have access to any solder paste right now, so I'm just going to have to do this by hand, but it's not too bad of a process. What I'm going to do is just go ahead and peel back the tape on this so I can access one of those chips. I don't want to peel back any more of the tape than that yet, because of course these little chips are going to want to go flying everywhere if you do that. But we'll go ahead and take one of those out. So there's two ways that you can put one of these chips on. You can put it down on the board in that orientation, or you can rotate the thing 180 degrees and put it in that orientation. And of course there is a right way and a wrong way to do that. You'll notice that these chips have a line on one side of them. So the line on that chip is going to be on the same side as this little notch that's in the corner of the silk screen on the circuit board there. As long as you haven't taken all of the chips off of your board, it's not hard to figure out which way they go anyway, because they all go in the same orientation for the one row. So to me at least, that the white line is on the left side of the chip. I think for you guys that means it's going to be on the right side. But anyway, all of them will go in the same orientation, and you just have to kind of continue the pattern that's already there. So easiest way to do this is going to be to come in here with your soldering iron and some really fine solder. You want to be using really thin solder, something like this is 20 thousandths of an inch thick, or about 1/2 millimeter. You're going to come in here, you're going to place your soldering iron on one of the pads and put just a little bit of solder on that one pad. And then you're going to come in with your chip, and the fire department is going to come to your house because reasons. So after you get a little bit of solder on your pad, you're going to take your chip, you're going to hold it with the tweezers, you're going to put it right about in the center of the pads, and you're going to heat up that one pad that has the solder on it and let the chip sink down into that. And you're going to want to make sure that your chip is nice and straight so you can solder the rest of the pins on. So now what I'm going to do is just go through here, heat up one pin at a time, flow a little bit of solder into it, and just pretty much do this over and over. Obviously, the one thing you're going to be careful of is just, you know, don't touch any of these other capacitors or resistors or anything with your soldering iron tip, because you don't want to dislodge them. But you're just going to go in and solder all of your chips on like that. You may find that adding a little bit of flux to the area that you're soldering helps you as well. I'm going to go ahead and just put on all of the chips, and then I'm going to go back through and solder all of the chips down completely afterward. This board truly is not all that friendly to being repaired. It is definitely meant to just be manufactured once and just not touched after that. But it's possible to get in here and repair it. It's not the worst thing in the world to try to repair. It's not like trying to repair a MacBook or something. That would probably be a lot worse than this. But now, I definitely wouldn't recommend this be your first soldering project if you've never messed with this kind of stuff before. It's not too difficult if you have some experience, but it's not the friendliest thing to work on for sure. Mostly because everything is in here so tight. There's a lot of little things that you can mess up. And if you do what I just did and you accidentally bridge a couple of the pins, you can come in here with just a bit of flux. And sometimes the flux itself is enough to help the solder flow to where it's supposed to, but if it's not, you can take the solder wick and do the same process what we did before. You can just lay this in here and pull the solder back off of those pins without too much of an issue. Of course, if you accidentally melt all the pins and move the chip around, that kind of makes it a pain, but nothing that we can't fix. Alright, so I have soldered on all 11 of our new chips. All of the solder joints look like they should at least work. They're not the prettiest job I've ever done. One thing I did notice is it looks like there's some damage around the chip for port number 21. And I'm not sure if I caused that damage or if this was like that before. And I say that because I do remember one of our original brains from when we first got our V5 stuff, port number 21 never worked on it. So it's possible that that was damaged straight from the factory, but it's also entirely possible that I did it as well. But one final inspection, all of our chips are in the correct orientation, so it should be ready to go ahead and throw the two halves back together here.
The trick with this is going to be getting the ribbon cable back in and then getting all this stuff back in here and having it function properly, particularly this little plastic piece. That is definitely the worst part to get back in. I'll go ahead and try to zoom out a bit just in case I go horrendously off the frame, which is entirely possible. So this little plastic dude goes into the two holes right here on the circuit board, and then that's just for the button presses. The trick is getting all this back together without having this piece fall off or without having one of these little plastic things from the magnets fall out. And I have seriously considered in the past just gluing those magnets down, because that seems like it would work a lot better than just having them floating there. But anyway, step one to reassembly is taking our board and we're going to push this ribbon cable back into this connector, and then we're going to close this little black flap down on top of it. And that should be a relatively simple process. It's going to be quite difficult to film, so though of course it's one of those things where filming it is going to be quite difficult, so I'm just going to go ahead and do the procedure that I just described. It should push up in there real nicely. You should be able to tell quite easily when it's lined up, and then you just push the little black plastic thing back down in place and you're done. Now you just got to get this little white thing back up under here, and you have to somehow hold that in place as you push this board back down into its resting place. It's a little bit of a pain. Sometimes it's just a lot of hope. Sometimes you have to align it with tweezers, and it's kind of a pain in the butt. Alright, there we go. I think everything's lined up for the most part. Just gonna get this to settle down on there. It's not wanting to go down for some reason. Alright, so one issue that has popped up here is when I was desoldering those chips with our hot air gun, we appear to have damaged this white plastic thing that's in here, and we should be able to access that just by pulling this top board off, which if I remember correctly, we should just be able to pull it straight up like so. And then this has all the really fancy processor goodness on it. But we'll set that off to the side, and this little plastic guy here has gotten damaged, which honestly what I'm going to do is I'm just going to take a pair of side cutters, I'm going to cut off the damaged part, and we're not going to worry about it too much. And that damaged part is actually where a screw goes through that holds the circuit board down. For future repairs, I might recommend taking this board and this piece of plastic out as well, but I think this should still go back together without much of an issue. Alright, so now we got to put these two pieces back together, and the first thing you're going to want to look at is to make sure that all these white plastic things are seated in here properly as they are now. Next thing you're going to watch, these little metal things just line up with the little hole here. Just make sure those aren't swung in the wrong direction. And then we're going to put this ribbon cable back in, and the process for that is just to slide the contacts back up underneath this connector. They should go in there reasonably far. You should be able to feel it pretty easily when it goes in the right spot. And then you just push the little black tab back down over the cable. So I'll go ahead and do that, and it's a little bit of a pain to line everything up, so I'm not going to try to film that exact process. Alright, now that cable is plugged in, the next tricky part is getting this little plastic piece back in place and having it not fall out throughout the duration of putting this back into this. So we're going to take this, we're going to line it up with the two holes that it drops into, which are about right there. And then I'm just going to like put a bit of pressure on that with the tweezers so it doesn't fall out immediately. Like that. So the tricky bit of this is putting this white plastic piece back in. There's two holes that it lines up with in here. And if you do accidentally knock the magnets out of place, I believe that these go in with this red stripe on the magnet facing down. So you kind of have to slide that in there, and then this little piece just sits on top. Just like that. And then this one goes in the same sort of way. This is the biggest pain of this entire process, is just getting this back together and having everything stay in place the way that it's supposed to. Alright, sorry about that. My camera battery died on me, but we're going to go ahead and try to get this little piece back in here without knocking anything else out. It's always a little bit of a trick, but we should be able to hopefully just hold that piece in as I line up everything else and get this board to drop down into place, kind of like so. And that should just go down about like that. And we should be able to push that button and feel it click, and we can. So that all should be good. We can go ahead and take our 4 screws that hold the circuit board down and put those back in. And with these screws, you just kind of want to snug them down. They don't have to be super tight. Just holding the circuit board in. And our button still works, so that's a good sign. And for now, what I'm going to do is just lay this back cover on. And we're going to go through and we're going to test all of our ports again to see if we've fixed them. My prediction, I'm thinking that port 21 is still going to be busted on this thing because it looks like the circuit board has some damage around port number 21. But hopefully the rest of them still work. So we'll go ahead and turn this thing on. See, our display still comes on. So now I am down to ports number 10, 18, and 21 are still having issues. So what I'm going to do is pop the back cover off again. And I'm just going to reflow the solder for ports 10 and 18. I don't think 21 is going to come back, unfortunately. But we can at least attempt to recover 10 and 18, which is that one. And let's see, 18 should be this guy, which I'm not even sure I actually remember pulling that one off. I might not have. Well, I can't explain why number 18 isn't working, and that is because I didn't actually replace that chip. I didn't quite take off enough of them. All these ones in a row were bad, and I didn't take off the last one I needed to take off there. So we're going to have to pull that one off of there. Now, I think I can get this one off without having to take the entire thing back off because hopefully this plastic post is far enough away and I can kind of direct the air that direction. But the other one is number 10, which is right here, which has some kind of nasty solder joints on it. So we'll see if we can't clean the solder joints up, and number 10 might just start working for us. And as I said, 21 looks like it has damage to the board, so I'm not going to bother messing with that one. I don't think that's worth my time. I think what actually happened there is I replaced chip number 13 when I didn't actually have to, but that is okay because we can still go back through here and get number 18. But let's put this back together. We'll see if reflowing the solder for the chip on pin 10 helped us at all. Devices. Looks like it didn't. I could try to replace the chip again, but there is still a chance that there's something wrong somewhere else in the circuit that's having issues there. Really happy that I've managed to fix as many as I have on this thing. Given what we started with, I think we're doing pretty good. Alright, so I went ahead and replaced the chip for port 18, and now it's functional. So solid red light shows up in 18. So there are 2 ports that are still not working. Those are ports 10 and ports 21. Port 21 has mechanical damage to it. I'm not sure why port number 10 doesn't want to work for me. By using this method, we have successfully repaired 9 out of 11 dead ports on this brain. So we've got about a little bit over an 80% success rate, which I mean, if you have a brain that only has, 6 functioning ports or something like that on it, there's no real harm in trying to go through and repair all of them, because hey, it's still a lot cheaper than it's a lot cheaper than having to buy a new brain. But anyway, that is how you repair these things. Again, this isn't necessarily legal if you're entering this brain on a competition robot. We're not changing how the thing performs. We're not making it any better in terms of static resistance or anything like that. But it is opening up a VEX component, and it's messing with the electronics on the inside. So I don't think that that is technically allowed by the rules. Hopefully you guys found that useful, and that's it for this video.